No big deal. We looked at some stuff yesterday that ought to make this pretty simple. If we want to multiply square roots like this, here's the trick. Now you tell me. If I wanted to write that first radical as an exponent, what would the power of x be? 3/2. Good. And it's 3/2 because, remember, there is an invisible 2 sitting on the radical that we don't write for a square root, and that's always what goes in the denominator. So we get x to the 3/2 times x to the 1/2. So you see the trick. If you write these as exponents, you can just use your properties of exponents that you're familiar with. And what do we do when we multiply like bases? What do we do to the exponents? We add them, sure. So we end up with x to the 3/2 plus 1/2 is x to the 4/2, which is what? 2. So there's our answer, right? No big deal. Okay, what if you had something like, instead, what if you had something like the square root of 9 times the square root of x? So what do you get there? This is 9/2 times x to the 1, okay? And so we add the exponents. So we end up with x to the 9/2 plus 1. But when we add fractions, we have to have a common denominator. So how would we write the 1? 2 over 2. Yeah, does that make sense? It's 1, but we got to multiply top and bottom by 2, so we have a common denominator. And really all we're doing here, I know we're adding fractions, but it's all in the exponent. So then we end up with x to what power?
X.
What's 9/2 plus 2/2? 11/2. Okay, but the answer needs to be written, what it's going to ask for. This is one of the questions real similar to one that's on the final, for example. They want you to write it as a radical in simplified form. So you got to use radicals. Okay, so this is the stuff we talked about yesterday. If we have x to some power and we want to write this as a simplified radical, remember that our goal is always to get as much out of the radical as possible, right? And so what was our trick? If we had x to the 11/2, how did we think about that 11/2? As a mixed number. Okay, so this is equal to x to the, what is it as a mixed number?
5 to 1.
Okay, 5 and 1/2, which means what goes outside the radical then? 5. There we go, x to the 5th, and then inside we get x to the 1, and then there's an invisible 2 there that we don't write, and there's our half, right? So in Moodle, if we're writing this in simplified form, it would just be x to the 5th times the square root of x, right? Okay, we good? Questions? Okay. So what about this one then? This is same kind of thing, only with cube roots, but it's no harder. How would we write this guy using a fractional exponent? Okay, and then what about that one? 3/3. Okay, so that's going to give me what overall? 8/3 plus 3/3. What is that? 11/3. And so we got to do the same trick. What's 11/3 as a mixed number? So 3 goes into 11 how many times? 3 with how much left over? 2. Okay, so then that would look like what power of x outside? And what power inside? Yeah, x to the 2/3, right? Okay, no biggie. You got that? All right, dividing. So let's talk about multiplying, no big deal. Let's talk about dividing radicals. So we've done this before. It's been a little while since we talked about it. Do you remember saying that when we, well, first of all, if we've got the square root of some fraction, we can always try to reduce the fraction. Like, for example, if this were 12x to the 7th over 8y, 12 over 8 would reduce, right? And that'd be good to do, make things simpler. We could, if we had x to the 7th over x, we could cancel an x there, and that also would be a good thing to do, make things easier. We can't do that here, though, right? Nothing simplifies, no part of that fraction is going to simplify. So we're stuck with the fraction. What did we say about taking the square root of a fraction? If we take the square root of a fraction, what can we do? Yeah, we can just split it up into the square root of the top and the square root of the bottom, right? So we end up with, we can break this up into the square root of 12x to the 7th, and we did some practice with stuff like that yesterday, reducing it. And on the bottom, we get the square root of 7y. So let's reduce, first of all, anything that we can. On the top, we're going to have an outside part and an inside part, probably, right, that we can reduce. What about the number? If we take the 12 and we factor the 12, what's it factor into? 2 and 6, and 6 is 2 and 3. Okay, so we end up with a couple of 2's and a single 3, right? So what's that mean in terms of the number part then? What's out and what's in? 2's out, good. 3's in. And then if we look at the variable part, well, we just did a bunch of that. If we have x to the... All right. Okay, just leave your stuff here. Okay, back to business. So where were we here? We said we dealt with the 12 on the top, but now we've got the x to the square root of x to the 7th. What is that as a fractional exponent? X to the 7/2. And if I write that as a mixed number, what do I get? X to the what? 3 and 1/2, right? Okay, why don't you, everybody close them up, have a look. You're going to have a tough time with this if you don't get it now. So what about the bottom? Nothing I can do on the bottom, right? 7, I can't simplify a radical 7. No part comes out. 7's prime. And I've just got a y. So what do I do with the bottom now? We got to think back to our discussions about how do we simplify square roots of fractions. If I have a square root on the bottom, I can't have a square root on the bottom. What do I do with a stranded radical? Like if I had something like earlier in the year, yeah, what if I had something like 3 divided by the square root of 2? What did I do to simplify that? Okay, good. I multiplied top and bottom by the stranded radical. So I multiplied both parts by the square root of 2. And what happens if I multiply a square root by itself? It cancels the square root. So I would just get a 2 on the bottom, right? And on the top I would have gotten 3 radical 2, and that would have been my answer. So the same thing applies here. If I've got a stranded radical on the bottom, it's this time instead of being a 2, it's a 7y. What am I going to multiply top and bottom by? Square root of 7y. Okay, so that's the next step then. We're going to multiply both the top and the bottom by whatever radical stranded on the bottom. And so what do I get on the bottom then? 7y. Whatever the stranded radical is, when I multiply it by itself, it cancels the radical. So I get 7y. And then on the top, all I've got to do now is just multiply this stuff out. So outside of the radical, I've got my 2x. I've got the square root of 3x times the square root of 7y. Well, what's the square root of 3x times the square root of 7y? It is x cubed, you're right. What's the square root of 3x times the square root of 7y? Okay, so I'm just going to multiply this stuff inside the radical. If I asked you what's the square root of 3 times the square root of 2, you'd tell me what? 6. Well, square root of 6. I just multiply this stuff inside the radical together. So I just have to multiply the 3x times the 7y, and what's 3x times 7y? 21 times x times y. The x and the y don't combine, right? So that's my finished product right there. Okay? Make sense? Questions? Okay, the only real difference being here that you can't have that stranded radical on the bottom. Everything else ties in pretty well with what we've been talking about. Okay, let's do one more of those. This time it's already broken apart into 2 fractions. Whoops, equals. So we can simplify top and the bottom. On the top, how could I simplify the number? What's going to come outside of the radical for the number? What's it factor into? 5 and 9, and 9 is? So I get a couple of 3s and single 5. So what's out, what's in? 3 out, 5 in. And then what about the square root of x to the 6th? What's that? Okay, x to the 6 halves, which is the same as x cubed. There is no fraction part, it's just all a whole number. So we get x cubed over the square root of 2y. I can't do anything to the bottom. Yes, ma'am?
So when you're, like, if you have something outside of the radical on the bottom, do you just multiply that on the inside?
Yes, you do. Good question. So what if you had a number out in front, you still just multiply by the radical part, top and bottom? Okay? Good question. So we're going to multiply top and bottom in this case by square root 2y, which gives us what on the bottom? Okay, and on the top. So now outside I've already got my 3x cubed. When I multiply everything under the radical, what am I going to get? 10y. That's it. Okay, and I'm stuck there. Can't go any further. Sometimes people ask the question, can I cancel the 10 and the 2? No, and how come? Yeah, good. The 10's inside the radical, so it's off limits, right? Just like I can't cancel those y's because this one's in the radical, okay? All right, what about something like this now? What if we're multiplying and dividing? This is no harder. In fact, probably a little bit easier than the last one we did. Oops. So let's do the same thing we've always done here. Let's just write these as fractional exponents. So what's the square root of z to the 7th? Z to the what? 7 halves, good. Times the square root of z to the 6th? 6 halves. I could write that as a 3. I'm going to go ahead and leave it as a 6 halves because I'm going to have to be adding these fractions up anyway. And then on the bottom? So what is that as a fraction? 1/2. Okay, so we said that when we multiply like bases, we add exponents. When we divide like bases, we what? Subtract. Okay, so then isn't this just equal to z to the 7 halves plus 6 halves minus 1/2? So I'm dividing by 1/2. So what's that give me? 7 halves plus 6 halves is what? 13 halves minus 1/2 is 12 halves, which is just 6. Okay? All right. So what about something like that? Okay? This looks harder, but it's not. We're just going to do the same stuff we would normally do when we multiply two binomials together. We distribute, right? But when we multiply the radicals, we just have to be careful about how we do that. Okay, so when I distribute the square root of x, what am I going to get? What's the square root of x times the square root of x? X. Okay, when we multiply two square roots together, square root by itself, it cancels the radical. What's the square root of x times negative 8?
Negative 8 square root of x.
Yeah, just negative 8 radical x. Now what if I distribute the 1? 1 times the square root of x is square root of x. 1 times negative 8. And then all I have to do is just add like terms. Are there any like terms up there?
Yes.
The radical.
Yeah, the square roots of x. I get the same radicals, and so those are like terms. They're like radicals. So these I can combine.
So would that be minus 7?
Yeah, negative 8 square roots of x plus 1 square root of x is negative 7 square roots of x. That's it. Okay. All right.
We're done for the year.
Done for today. Done for today. How about it? You can work?